Compute the derivative of secant x raised to the x minus 3 power. Let's begin by prepping this function. What we have here is this quantity secant of x raised to the power x minus 3. Now notice that since there's variables in the power, we can write this as a natural exponential, e to the ln of the base, secant of x, times the power, x minus 3. And so really this function is just a composition with the natural exponential. Its derivative is the chain rule. The derivative of e to the blank is e to the blank times the derivative of blank. So let's just fill in the blanks right now. We're going to have ln of secant of x times the quantity x minus 3. So the next order of business is going to be to differentiate this. Notice that this piece right here is a product of two functions, so we'll need the product rule. So the product rule says we differentiate the first term, but leave the second term untouched, x minus 3. Then we add the first term untouched, ln of secant of x, and multiply by the derivative of the second. Now the derivative of ln of secant is going to be 1 over blank, 1 over secant, times the derivative of secant, which is secant x tangent x. And the derivative of x minus 3 is just 1. So if we put this entire expression in brackets so that we distribute, we're going to have the derivative is e to the ln of secant of x times x minus 3 is the power, times this expression right here in parentheses. Let's clean this up. We have e to the ln of secant of x times the quantity x minus 3 as a power. Inside the parentheses, the secants cancel, so we're left with the tangent of x times x minus 3, and then the 1 doesn't matter, so we just have the natural logarithm of the secant of x. Now let's clean this up one more time. Notice that this expression can be again simplified. It can be put back as the secant of x as a quantity raised to the x minus 3. And then if we clean up on the inside here, I'm going to switch the order. We have x minus 3 times the tangent of x, that just reads a little better, plus the natural logarithm of secant of x. So this expression, that would be our derivative for this function right here.